Hey guys, in this video we're going to talk about converting between fractions, decimals, and percents. Okay, so the next type of number that we're going to talk about is a decimal number. And a decimal number is essentially the same as a fraction. It's just written differently. So a number with a decimal represents numbers with wholes and parts, just like a fraction. So right here is a little diagram of what each number in each spot means in a decimal number. So on the whole, we have the decimal point, which is this period right here. And to the left of the decimal point is the whole parts. And to the right of the decimal points is just the parts. Okay, so the whole is to the left, parts are to the right of the decimal point. So, and we can make it numbers as big as we want. So this isn't an exhaustive list here, right? Because we can have after thousands is 10,000s to the left, and then 100,000s. A million, we can make a number as large as we want to. And in a similar way, we can make a part as small as we want to, right? We can have thousandths, we can have 10,000ths, we can have, 100,000ths. We can keep going. We can make a part as small as we want to. So this is not an exhaustive list, but for now, we're just going to talk about these wholes and parts. So 1,000 is a 1 with three zeros. Hundreds is a 1 and 2 zeros. Tens is just a 1 and a 0. Ones is just 1. Then tenths, okay, so now we're talking about to the right of the decimal. A tenth is 1 out of 10. Okay, so it's a part. It's 1 out of 10, and we write it like this: 1 divided by 10. That's a tenth. In a similar way, a hundredth is 1 out of 100. Very small amount, right? Imagine a part that has 100 squares, right? A cake with 100 pieces, and only one is shaded. That's 1/100th, okay? In a similar way, 1,000th is 1 out of 1,000, all right? So let's talk about decomposing numbers with decimals into their wholes and parts, all right? So the first example we have right here is this number. We can say this number is 22.689. Okay, so that's one way we can say it. And to decompose this, we look to see what the wholes and the parts are. So we can see this number directly to the left of the decimal point is going to be in the ones place, right? It's in the same spot. And so this is going to represent the ones place. Directly to the left of that is the tens place, okay? So what this tells us is that I have 2 tens that make up this number, plus 2 ones, okay, because we have a 2 in the 10 spot, and we also have a 2 in the 1 spot, plus now comes the parts. So what's directly to the right of the decimal point is the tenths place, okay, and the 6 is there, right? So this is telling me that I have 6 tenths, so 6, 1 out of 10, plus directly to the right of that is the hundredths place, and it says we have 8 of those. So it's going to be 8 hundredths, 1 out of 100. And finally, we're going to add on to it. To the right of that is going to be our thousandths place, and we have 9 thousandths. Okay, so we have 9, 1 out of 1,000, which is really a small number. Think of 1 out of 1,000 as one piece of cake out of 1,000 pieces. Okay, so that is representative of 1 out of 1,000. So this is how we can decompose this number into its wholes and its parts. Okay, so again, a decimal number is sort of like a fraction. It is a fraction. It represents the same thing. And we can decompose it in this way. So let's look at decomposing this number right here. So directly to the left of the decimal point is my ones place. and I have 1, 1. Okay, so this is 1, 1. All right, and to the right of the decimal, I have my tenths place, and I have 9 tenths, and then I have 9 hundredths as well. So I have plus 9 tenths plus 9 hundredths. Okay, so this is 1.99 is this. It's all of this just expanded. So 1 times 1 plus 9 times a tenth plus 9 times a hundredth. That's 1.99. Now, let's go ahead and look at this example. We have a number 17.48. All right, and as we mentioned before, to the left of the decimal is the whole numbers. So we have 17 wholes as indicated by these 17 green squares. We have 4 tenths. Now what does that mean? That means if I have a cake with 10 pieces, I have 4 shaded. That's 4 tenths. Okay, we have 4 tenths. We also have 8 hundredths included here. So that means if I have a cake with 100 pieces, I have 8 of them shaded as indicated by these blue squares. So we can say this number as 17.48. Another way we can say this is 17 and 48. Okay, where does the last number terminate in the spot? This terminates in the hundredth spot, okay? So since it terminates in the hundredth spot, we can say 17 and 48 hundredths, okay? So that's how we can say that number. What about these numbers up here? So this guy terminates in the thousandth spot. So we would say 22, so that's the whole, and 689 thousandths. That's how we would say that number. We could say 22.689, or we could say 22 and 689 thousandths, because the last number after the decimal lands in the thousandth spot. How would we say this number? Well, the whole is just 1, so we would say 1 and 99 comes after and because that's the part. And the last number is right here, and it terminates in the hundredth spot. So it's 2 places after the decimal point. So this would be 1 and 99 hundredths. That's how we would say that number. So let's do some more practice with this. Let's practice actually saying the number and seeing what this number looks like in picture form. So let's go ahead and do some examples. So how can we say and picture the decimal number? So first of all, I'm going to first practice with you guys saying this number. So we want to say the whole number first. In this case, it's 4. So we would say 4 and now comes the parts. So 631 is the number we see. So we say 631. And the 1 ends in the thousandths place. So we would say 4 and 631 thousandths. That's how we would say this number. That's how we say it. Now, how do we picture it? Well, 4 wholes is just 4 whole cakes. I'm just going to do a little green square to represent my 4 whole cakes. So I have 4 whole cakes, and I want you guys to imagine that these cakes are just as big as these cakes right here. It's just that I don't have a lot of room to draw them that big, but we have 4 wholes, okay? Now, this number right here tells me that I have 6 tenths. So what does that mean? Well, I have a cake broken up into 10 pieces and 6 of them need to be shaded. So this is 4 holes, 6/10. 1, 2, 3, 4, 5, 6. Next comes the 3/100ths. So this guy has 100 pieces and I'm going to shade 3 of them. I'll do it in purple. 1, 2, 3, just a little bit right there. And finally, this number at the end is 1,000. So this cake right here is cut up in 1,000. So it's just going to be a little speck, just 1,000th right there. So that's how we can represent this number pictorially. 4 holes. And again, just imagine that these 4 holes are as big as those squares that we see. You guys get the picture. All right, so what about this number right here, 1.59? How do we say it? Well, we'll start with our whole. We say 1 and. Then after the and comes our parts. So the part that we see is 59. So this is 1 and 59. Now the 9 is the last number and it ends in the hundredths place. So this is 1 and 59 hundredths. Okay, so how do we illustrate this pictorially? Well, the only hole we have is 1. We have 1 hole, and maybe I should make this as big as our picture here. So that's 1 hole, all shaded. And the next number is the tenths place number. So this says I have 1 hole and 5/10. So I'm going to shade in 5 of these tenths. 1, 2, 3, 4, 5. And the last number is 9, and that's in the hundredths place. So I have 9 hundredths. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Just pretend these are shaded all the way. I can't get that great of a shade, but that's 9 hundredths. And we have 0,000, so none of those are going to be shaded. So again, this represents a hole and some parts, right? It's not quite 2 holes. It's 1 hole, 5/10, and 9 hundredths. And imagine squishing these together. That's how much of the part of a whole cake you're going to have. So 1 whole cake and 59 hundredths of a cake. Okay, let's look at this guy right here. So now there's no number to the left of the decimal, so it's understood to be a 0 if that's the case. So we have 0 holes, all right? How many tenths do we have? That's indicated by this number directly to the right, and it says we have 6/10. So 1, 2, 3, 4, 5, and 6. We have 8 hundredths, so I'll shade in 8 of these. 1, 2, 3, 4, 5, 6, 7, 8. And finally, we have 5,000. So this is going to be hard to shade in, but let's see. 1, 2, 3, 4, 5. So maybe like right there. That's about 5,000ths. So again, think about adding all of these pieces up together. That's not going to make an entire sheet cake, is it? It's going to just make part of one. And in particular, it's going to make 600. Let's put this in orange. It's going to make 600 and 85 thousandths, because the 5 lands on the thousandths place of a cake. Not even a whole cake there. All right. So let's do some practice decomposing the decimal numbers, just like we did on, a few slides ago. So again, in the thousands place, we have 1, 0, 0, 0. In the hundreds, 1, 0, 0. 10 is 1, 0. Ones is 1. Tenths is 1/10, 1 out of 100, and 1 out of 1,000. So how can we decompose this number right here? Well, we have 6 in the tens place, so this is 6 times 10, plus 4 in the ones place, so this is 4 times 1, plus 2 in the tenths place, this is 2 times 1 out of 10, plus 5 in the hundredths place, so this is 5 times 1 out of 100, plus 6 in the thousandths place, so this is 6 times 1 out of 1,000. So that is how we can decompose that number. Let's do the next one. So we have 1 in the ones place, so 1 plus 6 tenths plus 9 hundredths. Okay. All right. This time we have 1,000, so 1 times 1,000 plus 6, that's in the hundreds place, 6 times 100, plus 2 times 10, that's in the tens place, plus 8 ones, and now come the parts, plus 4 tenths, so 4 times 1 out of 10, plus 9 hundredths, so 9 times 1 out of 100, plus 3 thousandths, 3 times 1 out of 1,000. And this one we don't have in the diagram, but after 1,000 is going to be 10,000. We just add another 0 in the bottom. So this is going to be 8 ten-thousandths. That's a really tiny number, but not so tiny if you look at the grand scheme of things, I guess. So this is my number decomposed. All right, so how are we going to convert decimals to fractions? It's not too bad, actually, and you can use Desmos to help you out with this if you don't like doing a bunch of simplifying. What we're going to do is we're going to take wherever the number terminates and put it over that. So, for example, this guy terminates in the tenths place. So this is 8 out of 10. Okay, whatever the number you see divided by where it terminates. Okay, then you simplify. So if I simplify this all the way, if I reduce it fully, I can divide top and bottom by 2, and that's going to give me a simplified answer of 4 over 5. So 0.8 is equivalent to 4 over 5. Now 0.62, we take the number we see, which is 62, and we put it over where it terminates. Now 2 is the terminating number, and it terminates in the hundredths place because it's 2 places to the right of the decimal. So this is going to be 62 hundredths. That's how we write that. And we can simplify this guy. If I divide by 2, I know these are both even, so half of 62, half of 60 is 30, half of 2 is 1, 30 plus 1 is 31. Half of 100 is 50, and I don't believe this can be reduced anymore. All right, what about this one? We take the number we see, which is 318, and we put it over where it terminates. It terminates in the thousandths place, right? 8 is 3 places to the right of the decimal. So this is going to be 318 out of 1,000. And here I'm going to use Desmos to help me. So I'm going to do 318, the division sign, and then 1,000. And then I'm going to press the little fraction in blue to the left of the number that I just typed out. And I get my simplified fraction 159 out of 500. Just being lazy at this point. All right, what about a mixed number? This is a mixed number equivalent, right? It's whole and some change, right? These would be the equivalent of proper fractions, but this guy is an improper or a mixed number because it has wholes and parts. So how can we write this guy as a fraction? Well, we can write it as a mixed number because we can say, well, the whole part is 6, and the fraction part, we apply the same logic that we did in 1 through 3. So the fraction part is going to be 72 hundredths because the 2 ends in the hundredths place. And then we just simplify the fraction part. So 72 out of 100, I'm just going to put this on Desmos. Just being a little bit lazy here. Don't want to simplify manually. Press that fraction bar and I get 18 out of 25. So this is going to be 6 and 18 out of 25. That is my decimal number written as a fraction. Let's try the next one. So here our whole number part to the left of the decimal is 481. And to the right of the decimal is my part. So I have 624 out of 1,000 because the 4 ends in the thousandths place. All right, that's 3 units after the decimal. So now I can simplify the fraction part, 624 out of 1,000. Let's do it here. And I get 78 out of 125. So I have 481, 78 out of, what was it, 425? No, 125. And that is my answer as a mixed number. Now you can convert it to an improper fraction if you want, but I would just leave it mixed. All right, number 6, we have a whole to the left of the decimal. It's an 89. And my part is 2 out of 10 because the terminating number is 2 and it ends in the tenths place. Now I can reduce 2 out of 10, divide top and bottom by 2 to get 1/5. So as a fraction, 89.2 is 89 and 1/5. Okay. All right, fraction to decimal. This is so easy, you're not going to believe it. You just put it in the calculator, all right? Because what a fraction bar is a division sign. They mean the same exact thing, guys. So 4 out of 9 is simply 4 divided by 9. Put that in the calculator. I'm doing 4 divided by 9, and I get 0.44 repeating. Okay, that bar means repeating. So 3 divided by 8, 3 out of 8, 3 over 8, same thing, is 3 divided by 8. Put it in the calculator, 3 divided by 8 is 0.375. Now you don't have to put the 0 in the front. I'm just doing it just because I like it. I don't know. All right, 1 out of 2 is 1 divided by 2. That's 0.5 or 0.5 if you like it. 13 out of 7. That is going to give us, I'm going to round this thing. This is going to give us approximately 1.857. Okay. And it makes sense, right? Because this is an improper fraction. The numerator is bigger than the denominator, which means that it's a mixed number, which means that it's a decimal number with wholes and parts, just like this one. These guys did not have any wholes, and notice that all of the fractions that corresponded were all proper fractions because their numerators were smaller than their denominators. Anyway, let's move on here. So this, we have 2 and 1/6. I would change this to an improper first, or if you want, you can do 2 plus 1 divided by 6, but make sure the 1 divided by 6 is in parentheses, order of operations. Anyway, I would just change this to an improper fraction. So 2 and 1/6, we multiply these. 2 times 6 is 12, plus 1 is 13 over 6. So that's improper. When we do 13 divided by 6 in the calculator, we get 2.17 approximately. Okay. 2 and 1700ths is approximately this guy. All right. So 13 and 3/5, I'm going to write it like this. Now we do 13 times 5 plus 3 is 68 fifths. And, of course, we do 68 divided by 5 to get our decimal number. And we get 13.6. Okay, the last one here is 9. Okay, well, that's just, if we want to write as a decimal, I mean, if we really want to put the decimal point, we could put it right there and just put 9.0. As many zeros as you'd like to the right of it. It still means 9. All right, so we want to order these numbers from least to greatest. I think the easiest way to do these problems is to change all of your fractions to decimals first, okay? So let's go ahead and take a look at number 1. I notice that I have a fraction here and a fraction here that I can change. So this guy into a mixed number, 2 times 4 is 8, plus 1 is 9. So this is 9 divided by 4, which equals 2.25. All right, so this as a decimal is 2.25. So let's get rid of that and replace it with 2.25. 2 divided by 9 as a decimal is 0.22 repeating. And now we can order these. So the way that you order decimals is you check to see who has the biggest whole number first. If they all have the same whole numbers, then you go to onto the parts. So first of all, we have, let's see, we have 1, 2, 3, 4, 5 numbers in our list, and the first thing we check is the ones place, because they all have a 2 in the ones place except this one. This one has a 0 in the ones place, and since that's the case, this guy is going to be the smallest number. So 0.22 repeating comes first. We're ordering these from least to greatest. So since the rest of these numbers have a 2, we now look to the tenths place. So we look at all of these numbers and we compare, and we say, well, which of these numbers has the smallest number in the tenths place? That would be this number. This has a 2 in the tenths place, so that comes next. That's the next smallest number. So this is going to be 2.25. All right, now we have 3 numbers left. Now notice that these two have the smallest tenth place numbers, and so now we need to look at these two and compare their hundredths place. So which one has the smaller hundredths place? Well, neither of them. They both have a 9 in the hundredths place. So then we go to the thousandths place. This one has a 4 in the thousandths. This one has a 0 in the thousandths because there's no number in there. So that means this number is going to be smaller than this number. So this guy, 2.79, comes next in the list, followed by 2.794, and finally 2.8 is the largest because 8 is the largest number in the tenths place there. So this is our order from least to greatest. Let's try the next problem. So we have a list of numbers starting with 6 and 5/9, ending with 6.18999. And we want to order these from least to greatest. So the first thing I want to do is make sure everything is in decimal form so that I can compare numbers in their decimal form. And it looks like the only number that needs to be changed is this mixed number right here. So change this into a decimal. 6 times 9 is 54, and plus 5 is going to be 59. So this becomes 59 over 9. And when we do the division, when we actually put in 55 divided by 9 in our calculator, we get 6.55 repeating. So this is 6.55 repeating. All right, and then we just carry the other numbers down. And so now we can put these guys in order. Okay. All right, so smallest to largest. Well, right off the bat, we see there's only one negative number. So that has to be the smallest number, right? Any negative number is going to be smaller than a positive number, which is, the remaining numbers in our set. So the smallest number is definitely going to be -6, and maybe I'll write it down here. So we have -6 is first. And then what comes next? Well, 6 can be written as 6.0000, right? And since all of these have 6 in the ones place, now we need to compare the tenths place, which is the spot directly to the right of the decimal. Since 6 has a 0 directly to the right of the decimal. This one has a 1, this one has a 2, this one has a 2, this one has a 5. 6 is going to be the next smallest number, right? So 6 comes next. Next comes 6.18999 because, again, we're comparing 1 in the tenths place to the other numbers that are left. And notice that this guy has 2 in the tenths place, as does this one, and this one has 5 in the tenths place. So the smallest number in the tenths place is that one, and therefore this number comes next. Okay? All right, now we know that either this one or this one is going to come next because this one, this first number has a 5 in the tenths place, so it's going to be the largest. But which one out of the second or the third is going to come next in the list? Well, to determine that, we now need to look towards the hundredths place because the number in the tenths place is both 2 in both cases. So since this guy has a smaller number in the hundredths place, it's going to be the next on our list. It's going to be the next smallest. So this is going to be 6.234, followed by 6.253, and finally 6.55 repeating. So this last list is going to list our numbers from least to greatest. All right, let's take a look at our third one on our list. Notice that we only have 2 fractions to change into decimals first. We have this guy right here, and we have this guy. And 1 and 1/8, if I change that to a mixed number, 1 times 8 is 8, 8 plus 1 is 9, 9 divided by 8 is going to give us 1.125. So I'm going to change this with 1.125. And 11 divided by 10 in the calculator is 1.1. Okay, so now we have a nice list of numbers that we can order from smallest to largest. So let's first look at the ones place. Notice that all of these have a 1 in the ones place, in the whole number place to the left of the decimal, besides this one. This one has a 0 instead of 1, so it must be the smallest number. It doesn't have any whole parts. So our first number in the list, our smallest number, is 0.123. All right, now all of the remaining numbers have a 1 in the ones place, directly to the left of the decimal. So then we look to the tenths place and see which one of those is smallest. Well, the smallest numbers in the bunch are going to have a 0 in the tenths place, so we can kind of ignore these 3 for now. And now we're between this one and this one, first one and the last one. And so then, you know, now that we took care of the tenths place, we can look at the hundredths place and see, well, which one of these has a smaller number in the hundredths place? And the answer is this guy, right? Because this one has a 1 in the hundredths place, whereas the first one has a 0 in the hundredths place. So this guy, 1.001, is going to be smaller than 1.012. Because, again, 0 is in the hundredths place here, whereas here 1 is in the hundredths place. Okay, so that's that. Now, all of these 3 that are left have a 1 in the tenths place, so we look to the next number after that. And this guy has a 0 in the hundredths place. This guy has a 2 in the hundredths place. This guy also has a 0 in the hundredths place. So the competition is now between these 2, right? Because this one is obviously the biggest, since it has a 2 rather than a 0 in the hundredths place. So which one of these is smaller? Well, now we look to the thousandth place. So here 1 is in the thousandths place, but here 0 is in the thousandths place. So this guy is going to be smaller, right? So 1.1, and we can write the extra zeros if we want, but they're not necessary. Okay, so 1.1 followed by 1.101. And finally, 1.125 is the biggest number in our set. So those are our numbers ordered from least to greatest. All right, so now I have, it looks like I don't have any whole numbers in this set. I just have parts. So I want to first, since that's the case, I want to first look at the tenths place and see which of those has the smallest number for the tenths place. And let's see, we have 5, 6, 5, 2. It looks like 1 is going to be the smallest tenths place number. So 0.1 is our very smallest number here. Okay. Now we want to look at all of the numbers with 2 in the tenths place, since that's the next largest number. And it turns out this is the only one that has a 2 in the tenths. Oh wait, I'm sorry. This one does as well. So the next smallest number is either going to be 0.21 or 0.28. And which one is it? Well, it has to be 0.21 because when we look in the hundredths place, we see that 1 is smaller than 8. So that's how that goes. So now we have 0.21 comes next, followed by 0.28. The next number in the tenths place is 3. So now we look at our 3's. So I have this guy has 3 in the tenths place as well as this guy. And that's it. So which of these is smaller? Well, this one's smaller because 5 in the hundredths place is smaller than 8 in the hundredths place. So next comes 0.35, followed by 0.38. All right, the next largest number is going to be 4, and there's only one of them. So we know that one has to come next, 0.49. Now we move up to 5, and so I have this one has a 5, this one has a 5. Which one has the bigger number in the hundredths place is going to be this guy. So the smaller out of the two is this one, 0.51. So we have 0.51 comes next, followed by 0.54. And finally, our last two are going to have a 6 in the tenths place. And which one is smaller is going to be 0.6 because it has an understood 0 in the hundredths place. So next comes 0.6, and the largest of the numbers is going to be 0.62. So these are numbers from smallest to largest. All right, so we talked about decimals and fractions and how to go between the two, right? They're the same kind of idea. Fractions and decimals represent numbers that may have parts with them, so wholes and parts. The next sort of special concept that we're going to talk about is a percent. Okay, so the word percent, think about what cent means, okay? Percent means per 100, okay? So when we say 40%, we mean given 100 squares, 40 of them are shaded. That's what that means. 40% means 40 squares shaded per 100 squares. And the way that we can write it is 40 with the percent sign after it, or as a fraction we can say 40 divided by 100, 40 out of 100, okay? So that is what percent means, per 100. So let's practice writing these numbers as percents, fractions, and decimals. So first of all, we want to look and see so we're given some kind of whole, right? And we want to see how many pieces are in the whole, right? That's going to tell us if we can find a percent easily. A percent, we're always doing per 100. So if we count the squares in the grid, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 across and 10 down. And therefore, there's 100 total squares, right? So as a percent, since there are 100 total squares, we count the number of squares that are shaded. And that's going to be what? That's going to be, well, each of these each of these columns is 10. So this is 10, 20, 30, 40, 50, 60, 61, 62, 63, 64, 65. So this is 65%. 65 squares shaded per 100 squares. That's what that means. So as a fraction, we can represent this as 65 out of 100. And we can reduce if we want to. So if we reduce 65 out of 100, if I divide top and bottom by 5, I know that both of these are divisible by 5. 65 divided by 5 is 13, and 100 divided by 5 is 20. So our reduced fraction is 13 over 20. That's 65%. Okay? As a decimal, you can just put the 13 out of 20 in the calculator, right? So 13 divided by 20 in the calculator is going to give you 0.65. This is 65%. 0.65. 65%. All right, excellent. Let's try another one. Okay, so let's look at this one. First of all, how many squares in total do we have? We have 100. If you don't believe me, count them. There's 100 squares in the total diagram. How many are shaded is going to tell us what the percent is. So how many are shaded? Well, we have 10 shaded here, 10 shaded here, that's 20, 21, 22, 23, 24, 25, 26, 27 shaded. So as a percent, this is 27%, 27 shaded per 100, okay? As a fraction, remember what 27% means. It means 27 per divided by 100. And then, I don't know, does this reduce? Maybe. No, it doesn't. Okay, so 27 out of 100 is our final answer here. Now, as a decimal, 27 out of 100 is 27 hundredths, right? So this is 0.27. You could also punch this in the calculator, 27 divided by 100, to get your decimal representation. So each one of these, you guys, means the exact same thing. These are just different representations of the same amount, okay? So let's check this out. Oh, this is interesting. So now we have 100 squares here, 100 squares here. And so what is this going to be as a percent? Well, we have 100 squares shaded, right? Plus 10, 20, 21, 22, 23, 24, 25. So per 100 squares, how many do we have shaded? We have 125 shaded per 100. So that's 125. All right, percent. So more than a whole, right? Now, as a fraction, this is going to be an improper fraction, which makes sense. This is more than one whole. So as a fraction, we have 125 shaded out of 100. And we can reduce this by 5. So let's see. That's going to give me 25 out of 20. And we can further reduce by 5, divide top and bottom by 5 to get 5 out of 4. So our fraction reduced is 5 out of 4. As a decimal, if you do 5 divided by 4 in the calculator, you're going to get 1.25. So that's our decimal representation. Okay? Another way, like if you want to go from decimal to percent, you can just multiply this guy by 100. All right, so that's one other way to do it. Okay, so that was an instance of where we have a percent that's greater than one whole. We have one whole and some change. Okay, well, let's take a look at this one. Now, notice that we can't straight off the bat write a percent because we don't have 100 squares. Remember, percent means per 100. So what we should do first is we should actually write this as a fraction first since we don't have 100 squares. So as a fraction, how many are shaded? We have 1, 2, 3, 4, 5, 6 shaded out of how many in total? 1, 2, 3, 4, 5 times 1, 2, 3, 4. 5 times, 1, 2, 3, 4, 5 times, yeah, sorry, my brain is moving a little bit slow for this video. Okay, so this is a fraction, right? Now, if I want to figure out what the equivalent percentage is, now I can reduce this if I wanted to. I can reduce this by 2. If I divide top and bottom by 2, I get 3 out of 10. So this is my fraction. And I want to figure out, well, 3 out of 10, that's not really telling me per 100. So here's the idea. Here's where equivalent fractions come back. Let's cut up the sheet cake not into 20 pieces. Let's cut it into 100 pieces. Do you remember how we did that mathematically? So we want to cut these squares into 100 pieces, and I'm just like, not drawing this accurately because it's going to take way too long to dice that into 100 pieces. But remember how we can do that algebraically. I want this to be out of 100 so that I can see what the percent is. If I can see what number out of 100 it is, equivalently, I can get the percent. So how can I change 10 into 100? What can I multiply 10 by? Well, I can multiply 10 by 10 to get 100. So I have to do the same thing to the top. So 3 out of 10, you guys, is equivalent to 30 out of 100. That means that if we broke up this sheet cake into pieces of 100, 30 would be shaded, and it would give us this exact area right here, this exact amount. So again, we're just finding an equivalent fraction that has a denominator of 100 so that we can easily see what the percent is. And we can see that the numerator is 30, and so this is 30 per 100. So that's 30%. Okay? So, and keep in mind, these two fractions are equivalent. So as a decimal, if you do 3 divided by 10, or equivalently 30 divided by 100, or equivalently 6 divided by 20, you are going to get 0.30. Okay, so that's our decimal representation. This was our fraction representation, 3 out of 10, fully reduced, and our percent was 30%. And it kind of makes sense from the picture, right? Because we know that 50% would have to be just all of this half shaded, right? But since we only have 30%, we don't have quite that much shaded. Okay, so let's take a look at this one. We want to see, first of all, what percentage of this grid is shaded. And the second question is, how many more squares need to be shaded so that 80% of the grid is shaded? So what I encourage you to do is pause the video and try this one out on your own. All right, so let's go through it. Now, what percentage? We want per 100, but our grid, if we count it, only has 25 squares. All right, so 5 by 5 is 25. So the first thing I want to do is I want to actually write this as a fraction. Since there's 25 total pieces and there's 10, 11, 12, 13 pieces shaded, this as a fraction is represented by 13 out of 25. Now I want to reframe this as a percent. Now I can do one of two things. I can say, okay, well, I want to see what this is out of 100, so I can change 13 out of 25 to be an equivalent fraction to 100. And to do that, I need to multiply 25 by 4 on the bottom to get 100, so I do the same thing on the top. Now 13 times 4 on top is going to give me 52, and so this is 52%, 52 out of 100. So we know 52% of the grid is shaded. Now another way we could have done this is we could have just taken our original answer, 13 divided by 25, put it in the calculator. So 13 divided by 25 is going to give me 0.52 in the calculator. And then you take that and multiply by 100 to get what your answer is. Your percent is going to be 52%. So if you want to do it that way, go ahead and do it that way. But yeah, so 52%, right? So this is going to be This is going to equal 52%. That is the percentage of squares that are shaded on this diagram. Now the next question says how many more squares need to be shaded so that 80% of the grid is shaded? Well, the amount of pieces that we have is going to be the same, but this time 13 pieces are not going to be shaded. We need to figure out how many need to be shaded out of 25 to equal 80%, right? So 80%, once again, is going to be 80 out of 100. So this little equation says what number out of 25 is equal to 80 out of 100? What is that number that makes these fractions equivalent? And you say to yourself, okay, well, to get from here to here, to get from 100 to 25, I have to divide by 4. So I have to do the same thing at the top to get equivalent fractions. So 80 divided by 4 is 20. So 20 is our missing number. 20 out of 25 pieces, let's write it up here. 20 out of 25 pieces is the same thing. It's equivalent, completely equivalent to 80 out of 100 pieces. Think about 100 slices of cake here. Think about 25 slices of cake here. All right, so our answer here is, well, how many more squares? We know that 20 squares need to be shaded in total. This shows 13, so we need to shade some more squares to add up to 20. 5, 10, 15, 20. So how many did I shade? I shaded 7 more to give me a total of 20 squares shaded. So that's the answer there. Okay, let's do some practice converting between the three forms, fraction, percent, and decimal. Let's say I give you 3 out of 5 as a fraction. Now, as a percent, I want to think about this as per 100. I'm going to do the little shortcut first. You can use equivalent fractions if you want. Actually, I'm going to do that. I'm going to do it both ways on this one, and then for the rest, I'll just kind of do the shortcuts. So 3 out of 5, if I want to write this as a percent, I want to see what number out of 100 is equivalent to 3 out of 5. So on the bottom here, I have to multiply by 20, so I do the same thing at the top. 20 times 3 is 60. Therefore, 3 out of 5 is equivalent to 60%, 60 out of 100. Now, as a decimal, I can just do 3 divided by 5 in my calculator, and I get 0.6. Or if you want to write it like this, 0.60, that works too. 60 hundredths, all right? Okay, let's go ahead and do this the shortcut way. If I do, if I'm given 3 divided by 5, 3 out of 5, I do 3 divided by 5 in the calculator. I get 0.6, then I multiply by 100 to get my 60%. That's the shortcut. All right, let's look at the next one. We are given 42%. So as a fraction, well, actually, as a decimal, this is 42 hundredths, right? 42 per 100, all right? So as a decimal, this is just 0.42. If you were to put this in the calculator, that's what you get, 42 hundredths. As a fraction, 42 out of 100 can reduce. So if I start with 42 out of 100, and I first divide by 2, half of 42 is 21, and half of 100 is 50. And I don't believe this can reduce anymore. So we are just left with 21 out of 50 for our fraction. 42% is our decimal version, and 0.42 is, 42% is my percentage, and 0.42 is my decimal. Okay, let's look at the next one. So we're given the decimal is 0.43. Now, this is 43 hundredths. So as a fraction, this is 43 out of 100, which we know means 43%, right? So this is 43% as a percentage. Can I reduce 43 out of 100? I don't believe that I can, so that is our fraction. Okay, now we have 9 out of 20. First thing, I'm going to change it to a decimal by putting 9 divided by 20 in my calculator to give me 0.45. 9 divided by 20. Now, for a percent, what I can do is I can do the shortcut. I can take 0.45, multiply by 100 to give me 45%. All right, let's move on to the next one. We have 7/8. What is this as a percentage? Well, if I put 7 divided by 8 in my calculator, first of all, as a decimal, it's going to give me 0.875. Now, to get it into percent form, I can do 0.875 times 100, and that's going to give me 87.5%. If the shortcut doesn't make sense to you, if you don't like it, just continue to do the equivalent fraction process that we did before, but just another way we can do it. Okay, 16 out of 10. So as a decimal, if I do 16 divided by 10 in the calculator, that's 1.6. As a percent, I can take 1.6 times 100, and that's going to give me 160%. So that's my percent. All right, keep in mind that all of these groups here are all the same number. They're just written in different forms, okay? So let's do a little summary. So going from fraction to decimal, we just divide the top by the bottom in our calculator. If it's a mixed number, we want to change it to an improper fraction first and then do the division. So for example, 3 1/8 is a mixed number, so I'm going to first turn it to an improper fraction by doing 3 times 8 is 24 plus 1 is 25/8. Now I'm going to carry this division out in the calculator. 25 divided by 8 is going to give me a final answer of 3.125. So that's how we do that. Now, if I want to go from a decimal to a fraction, I want to first divide the decimal part by 100, 10, or 1,000, depending on where it terminates, and then I want to reduce. So, for example, this is a decimal number, and it has a whole part 2. So, as a mixed number, this is going to be 2 on the outside. And then the top part, the numerator, is going to be 48, and where it terminates is the denominator. So it terminates in the 100th spot, and therefore our denominator is going to be 100. Now we can reduce 48 divided by 100, and I'm just, you can do this on Desmos, or if you need practice, you can reduce it by hand. But this reduces to 2 and 12/25, and that is our answer there. Okay, let's go ahead and do the last one. From fraction to percent, we want to get an equivalent fraction with 100 as the denominator, and then the numerator is the percent. That's the first way we learned how to do this. So for example, if we have 3 out of 50, we want to see what this number is per 100. So we put 100 on the denominator and we say, okay, well, I have to multiply 50 by 2 to get 100 on the bottom. So I do the same thing on the top. 3 times 2 is 6, and therefore 3 out of 50 is 6%. That's the numerator right here. So that was the first way we did it. The second way was to turn the fraction into a decimal and multiply by 100. So this guy is going to be 8 divided by 23. That's how we change fractions into decimals. And in the calculator, I'm going to get 0.3478. I'm just rounding it. And then if we multiply that by 100, we're going to get our percent. We're going to get 34.78%. So that was the second way you could do it.